Hey guys, today we're doing Chapter 10, Section 5. In the last section we looked at the standard normal curve and the parent function of the normal curve, and we just looked at some properties, just kind of an introduction to the normal curve. Now we're going to actually learn how to use those standard normal curve in order to calculate probabilities. So hopefully you guys have this sheet in front of you. If not, it is in your book in the appendix, so it's Appendix D. And this is going to give us our standard normal distribution probabilities. So remember that the area between the standard normal curve and what we call the z-axis is 1. It's called the standard normal distribution because the curve's mean is 0 and its standard deviation is 1. Recall when we use z-scores at the end of Chapter 3 that this is the mean and standard deviation of any set of data which is transferred into z-scores. The standard normal probability distribution is a distribution of z-scores. Okay, so we talked about z-scores before, and remember that in order to get a z-score, we took the mean, we took our value minus the mean and then divided it by the standard deviation. And what that did was it standardized our score so that we could take anything that's standardized and compare it to anything else. So this is really useful because as long as we can find a z-score for something, we can calculate the probability of that happening using the standard normal distribution table. So using the table of probabilities, notice that on the table it says the probability that z is less than 0 for a greater than or equal to 0. So looking at this table here, we've got our z-axis on the bottom. This is our f of x, that's just our standard normal curve. And then we've got this a value here. That a value is just saying, like, whatever a we're looking at, it's just some number on our z-axis. And we're reading this as the probability that z is less than a for a greater than or equal to 0. In other words, if I were to look at this a value here and I were to shade everything behind it, that's the probability that I'm calculating. Okay, so looking at the table here, for 0.00, I have a 0.5 probability. So in other words, when my a value is 0, okay, that means I'm at this line right here, and I'm shading everything behind that line. Well, everything behind that line is just half of my function. I know that the whole area under the curve is 1, so half of that would be 0.5. So then if I want to look at 0.01, I look at the 0.0 here, and then I go over to the 1. So that would be 0.01. If I want like 0.23, I would go down to 0.2, and I would go over to 3. Okay, so that's how you read the chart. So using your table, remember that symmetry of the distribution can be really helpful. So if you know that you want to find something that's on the above your a value, well, that's just the complement of whatever's below your a value. The goal is to find the probability of a random variable falling within a specified interval of standard deviations from the mean. So number 1, find the probability that a randomly chosen observation from a standard normal distribution is less than 0.96. So we're looking for something being less than 0.96. For me, I think it's best when you start by drawing a picture. So I'm just going to kind of sketch my curve here. This is my 0. And if I want to be less than 0.96, I'll just put my 0.96 here, and I'm looking for everything less than that. So that's actually really easy because I can just use my table and I can look up 0.96, and that'll give me that probability. So on my table, I'm going to go down to 0.9. I'm going to go over to 6, and I get 0.8315. That is the probability that I will have something less than 0.96. Okay, next up, I want to find the probability that an observation from your normally distributed random variable falls within the given range. So if I want to find something that's between 0 and 0.96, I'm just going to start by sketching a little picture here. So here's 0, and here's 0.96. So I want this shaded area right here. Okay, so I cannot just get that from the graph. Okay, this table is not going to give me that number. But I can use my knowledge of the standard normal curve and of just graphs in general to figure this out. So I know that everything under that curve was 0.8315. And I'm just getting rid of all the stuff that's below 0. Well, all the stuff below 0 is just half of 1, so it's just 0.5. So I can take 0.8315 minus 0.5, and that will give me 0.3315. And that's going to be my probability for this one. Okay, next up I want everything bigger than 0.96. So again, just sketching that graph real quick. If I've got 0.96 here, I want everything shaded this direction. Again, my graph is not going to give me that. Okay, it gives me everything less than 0.96. Well, I know that the area under this entire curve is 1, and I know that all of this white area here is 0.8315, so I can just do 1 minus 0.8315, and that's going to give me 0.1685. Okay, next up, I want z is less than negative 0.96. Well, negative 0.96 is going to be back here, so I'm looking for this area here. Now remember that this graph is symmetric over the y-axis. So this area here, this negative 0.96, everything less than that, is going to be the same as everything greater than 0.96. So this is actually just the same thing, 0.1685. And this last one here, I want to find everything between negative 0.96 and positive 0.96. So I'm looking for this area here. This is probably the trickiest type that you'll run into, but it's really not that bad because if you look up here, we found the area between 0 and 0.96. That would just be this area. Well, I know that symmetrically speaking, it's going to be the same thing over here. So if I just double this area here, 0.3315, that'll give me 0.663, which is going to be that entire area. All right, last thing, what percent of data is within the following standard deviations from the mean? Well, remember that standard deviations are referring to when we have a standard normal curve, the standard deviation is 1. So looking at a z-score of 1, 2, and 3, what percent of values actually fall in that range? If I'm looking at one standard deviation, that means I'm looking at from negative 1 to 1. Because I'm looking at it from the mean, and remember that the mean is 0. So I'm looking for this area in here. Well, if I look at my table, at 1.00, I have 0.8413. So that means that this is 0.8413. Okay? So if I subtract out my 0.5, so I'm getting rid of this whole area here, and then I double it, because I want it twice, that will give me this area here, which is 0.6826. Okay, so that means that 68% of the values fall within one standard deviation of the mean in a standard normal curve, always. Okay, within 2 standard deviations, I'm going to do the same thing, except this one's with 2. So again, I'm looking for this area here. Well, if I look at my table is going to give me this, and that is 0.9772. Well, if I subtract out 0.5 from that and double it, I get 0.9544. So that means that approximately 95% of my values always fall within 2 standard deviations of the mean in a standard normal distribution. And within 3 standard deviations of the mean, I'm going to do the same thing. So looking at my table here, my table is going to give me everything less than 3. and that's 0.9987. I subtract out my 0.5 and then double it, that gives me 0.9974. So that means that 99.7% of my values are going to fall within 3 standard deviations of the mean. Okay, that's everything for section 5.